let's go ahead and look at what we have here. Thank you for getting more participation up on the board with the mechanical waves. So let's look at what mechanical waves are. Obviously, mechanical waves, and I agree with you, do require a medium. And remember what a medium was. It's air, water, earth, a solid figure or something, a solid and so a mechanical wave, and what we talked about is that how mechanical waves, if you think of physical, and because you need a physical something to allow it to happen, air, water, or earth, okay? So yes, they do require a medium. So let's go ahead and look at labeling over here. So we are to label just four things: amplitude, crest, trough, and wavelength. So let's look at A here. And I've only gotten a few answers. So A, I got a few more answers. So looking at A, which is right here, which one is this? Let me know in the chat box. Which one is this? Is it amplitude, crest, trough, or wavelength? Who can let me know? In the chat box. Let's go, folks. This is where we can participate. Good. Absolutely. Antoine's got an answer. Sally, look again. Sally, we're going to go over this, but it's, great guess. Love it. Give me some more answers, folks. Thank you. Andres has got an answer. Excellent. I'm seeing Daniel typing. Good morning, Daniel. How are you? All right, so it is, and I agree with you, it is wavelengths. Good. All right, let's look at the next one here. We're looking at B. B is going to having to do with this line right here, this blue line, going from the crest all the way to the equilibrium, which is that middle line right here, or from the equilibrium all the way down to the trough or the very bottom here. So with that being said, who can tell me what B is? What is this line right there? Good. Regine got an answer. Excellent. Catherine's got an answer. Excellent. Or Caitlin, I'm sorry. Caitlin's got an answer. Beautiful. Rowan's got an answer. Yes, I agree with you. It is amplitude. All right, next one is we're looking at C there. And C is obviously at the top of the mountain. I kind of already said the vocab word. So if you were paying attention, then you understand what that one is. What would that one be at the top of the mountain? Excellent. Regine's got an answer. Beautiful. I want to see some more. Rowan's got an answer. Caitlin's got an answer. Sally's got yes. Crest. Okay. I want to hear some from different people also. I'm hearing from the same people. And last but not least, okay, those who haven't answered yet, here is your chance. Last one. You have D right here at the very bottom of the valley. What is that vocabulary? Which word is that? Which word is that? I see one answer. Thank you, Regine. Rowan's got an answer. I want to see some different people out there. There's only one word left. We can do this. Thank you, Isaiah. Beautiful. Thank you, Sally. Beautiful. It is trough. Okay. Trough. All right. Excellent. Make sure we're participating at each and one of these because it does reinforce our learning for that particular lesson. So what do we do this weekend? Not very much. Played Fortnite, watched movies. Awesome. My husband got the new Star Wars movie, Squadron, so that's what he did all weekend. So I watched him play. That's pretty much it. Took some naps. Went to the store to get fall decorations for my room. I love decorating. Is that Regine or is that, let's see. Excellent. Let's see. Isaiah watched Formula One. I would have bet that would have been my good friend Antoine, but that's all right. I watched my niece all weekend. How fun. I wish I finished a good portion of my drawing. Excellent, Rowan. Beautiful. My pom-pom, it's a dog. It's having baby. Really? Awesome. Awesome. That's Ivana. That is super cool. Aren't they really, really small, though? Do they only have like 1 or 2 pups when they do have babies? Okay, so they're really small. So they only have like a very small litter, right? Like 1 or 2 pups. Yeah, okay, yeah. That's what I thought. How awesome, how fun. All right, yes, I see that. Excellent, excellent. Excellent. All right, here we go. Let's move on. So knowing that this Class Connect session is recorded and distributed for learning purposes, please do not put any personal information or information of others into the chat box. For your protection and protection of others, always be respectful and always make sure you're participating. Participate. It's so much. It makes class. I'm going to tell you right now, it makes class go by so much faster, and it's much funner to be in class when you're participating. All right, here we go. It is day 32 of 60 on our adventure together in trimester 1. It is Monday, October 5th, and we're going to talk about behaviors of waves. We're going to do slide 9 of our Unit 4 projects. So we're going to take a moment in just a second to talk about our project slides. Today we're going to do our October 5th attendance discussion. Again, heads up, make sure you stick around for that attendance to get full attendance credit for today. You cannot get attendance credit even though we know that you're in the chat box, that you've been participating, that you're here. We need to prove it. We need to verify that, and that is through our attendance discussion. So please make sure that you stick around for that. So we're chugging along Unit 4, and today we're going to be describing the characteristics of 3 types of mechanical waves and how we define them and how we see examples of them. All right. With that being said, I'm going to go ahead and hand this over to Mrs. Larkin, or it doesn't matter. I can do it. It doesn't matter to me, Mrs. Larkin. What would you like?
Sorry, I'm here. The audio was just not letting me speak. All right, everyone, good morning. All right, so what we're going to go ahead and do is we are going to go ahead and do slide number 9 today. I did set up slide number 10 too because we had hoped to be able to get through slides number 9 and 10, but we realized in the first class that we wouldn't make it to slide number 10, and that's okay because now that we're doing the projects and not the class assignments, we can be a little bit more flexible towards your needs, which is great. So let me go ahead and show you how this is going to work. I'm going to send you 3 links in the chat box. If you have already started your Unit 4 project, the first 2 links are for you. If you have not yet started your Unit 4 project because you weren't here on Friday or for some reason you didn't open it up on Friday, then you need to go ahead and click the last link. Make sure that you are logged into Google. You need an actual Google account. Your Insight email does not count as an actual Google account. You need to make a different Google account if you're trying to use your Insight email. So if you open it up and it says cannot access, that's because you're trying to use your Insight account and not your Google account. So please make sure you have a real Google account. It can be your mom's or dad's if you want to use theirs, or it can be your own. And we will, if you need that link, let us know and we'll private chat it to you. Okay, so here we go. There are 3 links I sent you. The first one is the first 2 are if you already started your project. So the first link sends you to where you find your original project, and the second link sends you to where you can copy the newest slides. The nice thing about this is the second link, all right, doesn't make you create a new copy, and so you don't end up with 5,000 confusing copies in your Google. All right, so let me go ahead and show you exactly what this will look like because I know this is kind of a new process, and we want to make sure that everyone's following along. If for some reason you're having trouble copying the slides, let us know. We will try to help you during class. If we cannot help you during class, we will go ahead and we will help you through email or whatever. We'll make sure to write down your name, or you can email us and just take pictures. Okay, so if for some reason you're running into errors, don't stress, just take pictures for now and then let us know and we'll make sure that you are able to get your slides copied. All right, so again, this is for the first people who have already started their project on Friday. All right, so let me go ahead and show you what this looks like. So again, if you already started your project on Friday, you're going to go ahead, scroll up and click on the first link where it says docs.google.com/presentation. And that will open you up to your inverted means the opposite colors. Haley, we'll go over that when we jump into talking about light. Currently, we're still just introducing waves, so that's why we haven't yet done that slide. Awesome. But yeah, that is a reminder. If you haven't already, make sure you start getting started on your project, on your artwork for your project. Okay, and if you need more directions, that was all on Friday. So again, this is your folder, all right? So you can find your old one. I have a bunch of them just because I've demoed this several times. But here, for example, this is the one that I did with you all. So here was the original copy that I had of the Unit 4 project. All right, so I'll go ahead and open up my original. And then again, you need to click on the second link in order to find the newest slides. So you should see that you have slides 7 and 8 already completed. Awesome. Go ahead and click on that second link in order to open up the newest slides. All right. All right, now this one you will not be able to edit, and that's how you know that this is not your project. So if you're like, oh my gosh, there are two windows open, they're so confusing, they look the same, one of them you can edit, one of them you can't. So this one you cannot edit. So all you need to do is go down to slide number 9, which is what we're doing today, and click on it from the slide area. All right, and then you're going to right click on it and click copy. So again, right click and click copy. You can also press Control C. It gives you that shortcut right here on the right. All right, so copy that one and then go back to your original, and in the same slide area, click over here, right click. You can just click on slide 8, right click, and click paste, and that will put slide number 9 in your original project. Go ahead, give me a rainbow in the chat box if that is making sense. Awesome job, Sally. Rainbow in the chat box if that's making sense. Again, you should also do slide number 10, so I'll show you another example. Here's the one that you cannot edit. Antoine, all the links are in the chat box. Okay, I'll tell you if you can't find your old project, I'll tell you how to do the new one. I'm just helping students who already have their old project. Okay, so just hold on, Antoine, and I'll help you make a different one, okay? I'll help you make a new one if you can't find your old one. Not a problem, all right? So right here's slide number 10. Same thing, click on slide number 10, and then right click on it to copy it. All right, so here we go, we're gonna copy that. Jump back over to your original, again, right at slide 9, right click there, and then click paste. And now you have your two newest slides in your original project, and you don't have to make a bunch of new templates, so your Google Drive is nice and clean, okay? It's not in the recent list. Okay, so there you go. Let me go ahead and show you how to do this. Antoine, so here is your original. Just go up to the search bar and click type in unit 4. So if you go up to the search bar and type in unit 4, you should find it right there, right? And find the one that's owned by you, all right? Not the one owned by me, okay? All right, let me know if that helps. So again, that search bar is your friend. Now, on the other hand, if you did not start your project on Friday, that's okay. You still have time to get caught up. So go ahead and click that last link where it says, do you need to start your Unit 4 project? Click here to make a copy. All right, so if you have not yet started, you can make a copy of the newest template by just clicking on that last link. Go over here, click make a copy, and voila. Here you go. So you will need to make sure that you go back and complete slides number 7 and 8 based on Friday's class. And today we're working on slide 9. And then taking a look over here, don't forget to fill in your name for slide 3. And don't forget that the project, you're going to be drawing some art. It can be as simple or as complex as you need. It should be hand drawn. It needs to have at least 5 colors. Remember, you need to take a picture of when you first start it with your name written on it, the middle of your process with your name written on it, and the final product with your name written on it. All right, so take pictures of all 3. Again, you can start it now. That way you are ready to go once we start analyzing our pictures. Okay? Yeah, if drawing's not your specialty, make it simple. It doesn't need to be complex. Draw me a flower, draw me a basic car, and just make sure that you have 5 colors. It can be anything that you want, Greta. It can be as difficult or as complex as you want. Rowan, the reason that it cannot be digital is for plagiarism reasons, just because there are a lot of tutorials online of how to do digital projects, and you could actually just screenshot them and say that those are your art. There's no way for me to prove that it's your art. So that's why we are doing them hand-drawn. Okay, but again, it can be as simple or as complex as you want. Okay, anything that's appropriate. Looking good, cool. All right, let's go ahead and jump back over here. Let's go ahead and do a brainstorm. Oh, sorry, actually, let me get green checks. Green checks, please, once you have copied your slides, or if you weren't here on Friday, you've made new slides. If you're having trouble, let us know in the chat box. If you're just going to take pictures and worry about copying the slides later, still give me a green check. Green checks, everybody. I'll go ahead and start the timer. I can't actually see the timer, but I'll go ahead and put it up there. Anyways, 30 seconds. I think I put 30 seconds up there waiting on Moises. Timothy, green checks, please. Kalia, Keon. Jaylyn. Jalen B, Jose. Thank you, Jalen. Waiting on Jadelyn L. Isaiah, Harmony, green checks. Adrian. Yeah, slides number 4 and 5 and 6, just kind of 4 and 6, you're just going to complete when you have time. And then slide number 5 will show you how to do when we talk about light. Awesome. Waiting on Moises, Keon. Again, each day we will tell you which slide to be working on. All right, but again, start your art. That way you just have it ready to go. Today we are working on slide number 9. I did give you slide number 10 because we thought we would get to slide number 10 today, but we realized in the first class we didn't have time. But the nice thing is we're no longer doing assignments, so we can be nice and flexible now. All right, Adrian, Harmony, Isaiah, Jose, green checks, Keon, Moises, green checks, everybody. All right, we are moving on. All right, so here we go. How many of you have ever played with a slinky? How many of you enjoy slinkies? I think slinkies are lots of fun. I have one right here. This is actually from my very first classroom. So this one is about 10 years old. Yeah, all right. So take a look here. What I want you to observe today is what happens when you wiggle a slinky. I'm also going to go ahead and put a GIF of it up on the board in case for some reason you have a hard time seeing my video. If my video is lagging a lot, this way you can still see it up on the whiteboard. All right, so let's go ahead and take a look at this example here. You don't have one, yeah, but they're a lot of fun to play with, right? Cool. Yeah, Slinky from Toy Story, the Slinky dog, awesome. All right, let's go ahead and take a look at an example here. See if I can get it centered. I am just, which way am I going? Here we go. All right, looking good. So here we go. I have my Slinky right here. Looks like you should be able to see it. And I want you to tell me, what do you observe happening as I wiggle it? If you were trying to describe the motion of a Slinky to someone who could not see it, right? Either they're not there or maybe they have a visual impairment, tell me, what would you tell them? What is the Slinky doing? Don't just tell me it's wiggling. I told you it's wiggling, right? So tell me, what does wiggling mean? It's your dog's favorite toy. They get, yeah. Awesome. Yeah, try to use your own words. Tell me, what do you see happening as we wiggle it back and forth? Again, you can see both the GIF up there as well as my video. Awesome. So we can see it's kind of wavy. We can see it's moving up and down, going back and forth, right? You can see kind of it's pretty energetic. Awesome. All of those things are good descriptions. Awesome. Yeah, it's making little hills. I love that description. I haven't heard that one yet, so that's very original, Brisa. Awesome. So that is what happens when we wiggle a Slinky. Now I want you to think about what happens when you push a Slinky. So let me go ahead and get a different one for you. I'm going to put this GIF up here and then show this one to you. And I want you to describe to me, again, imagining I'm not there or I cannot see it. What happens when you push a Slinky? All right, so let me center it. There we go. Tell me, what do you notice happening as I push the Slinky? Okay, remember the first time we said it makes little hills, it goes up and down or side to side. This time, what's happening as I push the Slinky? Yeah, it's cool. Yeah, so if you have a Slinky at home, you should definitely play with it this way. What do you notice as you push? Try to describe it to me. Awesome. Yeah, so it's pulsing. It's going from like one end to the other end. I think that's what you meant, Brisa. They're scrunching up and moving to one side. Yes, the rings hit each other and then separate. Yeah, this is actually a different type of wave. So we're going to take a look today at what type of wave this is. Awesome observation, Caitlin. Looking good, everybody. So yes, let's go ahead and actually jump in and talk about these different types of waves. I'm going to go ahead and turn this off, and here we go.
One, couple classes have, couple classes haven't, but if you have seen this slide, then it's a review, but if not, then let's go ahead and talk about mechanical waves. Now, mechanical waves do not move matter, okay? We have to understand that they do not move particles, they do not move the matter from one place to another. What they do is, though, that we know that the energy is what is traveling through that mechanical wave. Particles can go up and down, back and forth, and encircle, but they do not travel within the wave. It is the energy that travels within the wave. Just like we talked about with the stadium wave, people stand up, sit down, but you're not going to have a person going to be running, or people aren't going to be running around the stadium to get that wave. Okay, so we have to realize that people stay in their seats, but the energy just moves around the stadium. Okay, yeah, that would be such a dangerous and such a safety issue for people just to run around the stadium. But it is the particles that are, it is the energy that moves. All right, let's go ahead and look at what types of mechanical waves they are. Now remember, like I just said, that mechanical waves, the energy travels, but the particles stay in place or stay in their seats. There are three types of mechanical waves. The first type of mechanical wave is what we call a transverse mechanical wave. Those are where the particles move perpendicular to the energy. When I say perpendicular, I mean up and down, okay? So it is those people standing up, standing down. Now, the second type of mechanical wave is called the longitudinal mechanical wave. Those are particles that move parallel to energy. So just like Mrs. Larkin was taking the slinky and pushing it back and forth, and you saw that energy moving through that slinky, the slinky wasn't moving. It was the energy that was moving. That is a longitudinal wave. And then finally, we're going to talk about a surface mechanical wave. Those are which the particles move in circles. And I don't know if we saw this on Friday, but if not, we're going to see a demonstration about a actual like ocean wave and how it can be a surface wave. Okay. All right. So let's go ahead and actually before we go on, I just want to do a little quick check here. Go ahead and give me a star if this all makes sense. You have a transverse mechanical wave which moves perpendicular. That's up and down. The longitudinal wave that moves parallel to energy. Okay. And then finally, the surface wave that moves in circles. And we're going to talk about each one of these.
Beautiful. All right, so let's go ahead and take a look at longitudinal waves. Now, when you think of longitudinal waves, I want you to take a look at this prefix long and think of the particles move along with the energy. All right, so let's go ahead and take a look here. So think of long, think of along. And what this just means is that if the wave is moving to the right, then the particles are going to move parallel also to the right, but then move back as well, right? Because they go back and forth. So they'll actually go left and right. But they're going in the same parallel direction as the wave's energy, although they're not moving from their spot. All right. So particles in longitudinal waves, they move along with the energy. So they're going to move parallel to the wave's energy. This is just like our slinky, our push wave, right? As we push, the particles moved in the same direction. They didn't go up and down. They actually went in the same direction back and forth. So an example of this would be a sound wave. And this is really important to understand because sound, the nice thing about it being longitudinal is it can travel straight to your ears. All right, so they push the particles straight along to your ears, which if sound did not do this, if sound was instead transverse, which is up and down, or surface, which is just circular, then in order to hear sound, you would have to bob your head in order to hear sound. So you would have to go up and down with a transverse wave in order to be able to hear sound. So that's why it's so important that we can see here that the sound is coming straight at you. Okay, so that's a good way to remember how sound is working. Let's go ahead and take a look at a GIF of sound, and I want you to make some observations about what's happening with the colored particles. So let me go ahead and drop this up on the board and tell me in the chat box, take a look at one of the red particles and describe for me what is that one red particle doing. Try to be specific. What is the one red particle doing? I'll put the link in the chat box as well. The link is also in the chat box. It just might take a moment to load too. Yeah, awesome. So we can see that the red particles are moving left and right, left and right. Again, the link is in the chat box. So if it's not working on the board, just go to the link in the chat box, right? So it's going left and right, left and right, left and right. Now the overall wave is moving to the right. You can kind of see on the left, the wave is being pushed over to the right, but the individual particles, the individual red particles themselves are not moving away from their seat. Even though they're going parallel left and right, they are still not moving away from their seat. Okay, so again, taking a look at our sound wave, for example, even though sound moves from this speaker over to your ear, the energy moves, right? So this is our energy. The individual particles right here are not moving away from their spot. They're just kind of moving back and forth parallel, which should make sense because if the particles had to move with the energy, then every time you spoke, all of the oxygen in the air would move away from your mouth, which would make it really hard to breathe. So again, particles themselves are not moving away from their spots. All right, so this is going to be slide number 9 in your project. I'm going to go ahead and show this for you up on the board. Let me go ahead and share this with you. All right, so let's take a look here. We are going to be on slide number 9. All right, so we just talked about how sound waves are a type of longitudinal wave because the particles are moving along parallel to the energy. So go ahead, click on the edge of sound waves, hold and drag it over to the longitudinal box. That's where it should go, longitudinal box. Again, at this point, we should have already copied slides number 9 and 10 into our project, our original project, or if we did not start it on Friday, you can also just open up the newest copy. Open up the newest copy. All right, so again, if you need to copy, you can right click on slide 9, copy, jump over to your other presentation, right click and click paste, and that will put it in there. All right, go ahead and give me a green check once you have moved sound waves into longitudinal box or you've taken a picture. You have 30 seconds. Green checks, go, go, go. Timer's on the board. Awesome, great job, Sally. Green checks waiting on Adrian, Angelo, Antoine, Daniel, Eric, Harmony, Isaiah, Jose, Kalia, Keon, Luis, Matthew, Moises, Rishane, and Timothy. Green checks. Again, if you need to, just take a picture and you can worry about copying the slides later, but don't forget to copy the slides. You do eventually need to copy the slides. All right. I don't know if I can here shrink that down a little bit. All right, looking good. Yes, awesome. All right, Adrian, green checks. Eric, green checks. Isaiah A, Jose, Keon, green checks. Moises, Rishane, and Timothy. Rishane, I know you're here, so give me that green check. Let me know if you're having issues. All right, gonna go ahead and move a couple people. All right, the pictures we'll move later. We have another slide where we do those ones. Perfect. All right, everyone, let's move on.
Transverse waves a little bit in the beginning, but transverse waves are particles that move perpendicular. They go up and down in the direction of the energy's wave. They don't necessarily move. And so an example of this would be a guitar string. So any of my musicians out there who have played guitar know that when you strum your guitar, the strings are going up and down to make the sounds, and obviously those sounds combined will make your music. So when next time you do actually do if you actually strum your guitar, I want you to be very noticeable about how the guitar strings are actually moving, because that is what we call transverse waves. I'm going to go ahead and show you a little GIF here about a transverse wave, and if I can find it, there it is. Let me just grab it. I will put it in the chat box just in case you need it, and I do not want that. No. Here, so there's that link to the transverse wave. What's happening? Pick one of those red dots and tell me what is happening to that red dot. Excellent. They're flowing, going up and down. Just choose one. Don't, because then you'll get yourself sick if you choose like all of them. But yeah, going up and down. Excellent. Yeah, if you notice, oh, that's good, Antoine. As you notice, if you look at one of those dots, yeah, it's going up and down. Is that dot actually moving? Is that dot actually moving? Look at just one of those dots. Is it actually moving, or is it just going up and down? No, Regine, no, absolutely. So just like we said, it's staying in its seat. It is not moving, and so it never leaves that particular space. It's the energy that it travels to make it go up and down. Go ahead and give me a birthday cake if that makes sense. A birthday cake if that makes sense. Yeah, they do not move away from their spots. Excellent. Beautiful. Now, this is your part of slide 9, so I'm going to go ahead and show you a little bit about slide 9. And I'm going to open mine up really fast here. And I know this time around I'm pretty good. All right, here we go. Let me screen share that with you. So on our slide 9 here, and I'm going to move this over just a tad. Maybe not. All right. So on my slide 9, if you notice all the way down here, obviously I didn't put in any of these. I'm going to find guitar string. I'm going to obviously click on it, highlight it so it is blue all the way around. And when it's blue all the way around, I grab it and I hold and drag it to wherever it needs to be, which would be transverse wave. All right, I'm going to give you about 25 seconds to do that, 25 seconds to get that in. I'm going to put that up on the timer. Green checks when you got that in for transverse waves. Transverse waves, you're going to put guitar string. There you go, 25 seconds. You've been hungry ever since you woke up. Oh my goodness, have a good lunch. We're making everybody hungry. Alrighty, here we go. So just checking in with a few people here. Again, all you have to do is click and grab. Remember, make sure that you grab when it's all highlighted in blue. Click on the sides and then just hold and move your slide. So looking for green checks from Annabelle, green check. Looking for a green check from, thank you, Daniel. I saw that green check pop up. Haley, Harmony, Isaiah, green check, please. Looking for Jalen, Jose, green checks. Kayla, green checks. Matthew, green check. And yeah, there we go. Let's get those green checks in. Again, communicate with us if you're having issues, if you're having problems, because it's so important that you do that. We don't want to leave you behind, and we don't want to, if you're having some technical difficulties, please let us know. Mrs. Larkin's always starving by noon. Me too.
Awesome. All right, everybody. So let's go ahead and talk a little bit about surface waves. So we actually already took a look at surface waves on Friday, and we saw how they move in a circle. So the reason they move in a circle is surface waves actually combine perpendicular motion up and down with parallel motion left and right. And as those motions combine, you end up with a circle. Okay. Now, surface waves, much like they sound, happen at surfaces. So specifically the surfaces. Rishane, I don't know why it's copying slides 7 and 8. That's strange. If you want, you can go ahead and email us, and we can try to fix that for you. Okay. So I'll send you my email right now, and just show me, and we can go ahead and set up a time to get that fixed. Okay. Oops. Sorry. Oh shoot. Okay. Hold on. My computer's freezing right now. Okay. Sorry. It's back. Okay. Sorry about that. 1 second. Okay, perfect. All right, so let's go ahead and talk a little bit about surface waves. So again, they happen at surfaces between two mediums, which means that they can happen between like air and water. So those are two different mediums. Air is a gas, water is a liquid. And this happens in like ocean waves. So ocean waves are a type of surface wave, probably the one that we're most familiar with. They can also actually happen between air and earth. And so air and earth happens with seismic waves. All right, yeah, the video is lagging a little bit. So this happens with seismic waves, where these ones can actually also move in a circle. All right, so let me go ahead and show you an example of this. I'm going to grab the surface wave GIF here. And this time what I want you to notice is not what the particles are doing, because we already know what the particles are doing. They're moving in a circle. And we already know that they're staying in their spot. That's really obvious at this point. This time I want you to compare, what does the top circle look like compared to the bottom circle? How is the top circle different from the bottom circle? All right, we're talking about surface waves. So how does the particle at the very, very top of the surface compare to a little bit lower down underneath the surface? Link is in the chat box right there. Excellent. I see Rishane. Yeah, awesome. I see Rowan, Caitlin. Yeah, the top one is a lot bigger. All right, and this should actually make a lot of sense to us, because what I want you to think about is when you go to the ocean, all right, if you've ever been to the ocean and a big wave is coming towards you, does it make more sense to stand straight up or to duck underneath? In the chat box, what do you think? When a big wave is coming towards you, does it make more sense to stand straight up or to duck underneath? Yeah, and why do we duck underneath waves? Why do we duck underneath waves? I'm sorry, Antoine. Yeah, that's why the link's in the chat box. Yeah, because there's less wave motion underneath the surface. Just like you can see up here. Again, it's called a surface wave, and so the most energy and the most motion is at the surface. Whereas if you go down a little bit more, you can see that that surface wave becomes less pronounced, much smaller, and less energetic. Go ahead in the chat box, give me a star if that makes sense to you. Star if that makes sense to you. Yeah, so we don't get knocked over. Yeah, don't stand straight up if a big wave's coming at you. Duck underneath it. Excellent. All right, so again, right here we can see that particles near the surface actually make bigger circles. Bigger circles. They're much more energetic. Excellent. All right, this is going to be the other example for slide number 9 in your project. Let me go ahead and share that with you up on the board. And I'll try to shrink this down if I can. All right, cool. So let's take a look right here at slide number 9. All right, so we talked about how guitar strings are transverse, and ocean waves again happen at the surface of the ocean. So that goes in ocean waves. Go ahead and give me a green check once you have moved that. You have 30 seconds. Go, go, go. 30 seconds to fill in your notes for slide number 9. The examples of longitudinal, transverse, and surface should now be completed. Excellent. Waiting on a few more green checks. Annabelle, Bowen, Brisa, Bryant, Daniel, Greta, Harmony. Isaiah, we already did slides number 7 and 8 on Friday, and we filled in our name for slide number 3. Slides number 4, 5, and 6 we have not yet really done. Although you're welcome to start on your art for slide number 4. Remember that you need a piece of artwork. You need to hand draw art that has 5 colors. It can be as simple or as complex as you want. It can be any topic as long as it is school appropriate. You need to write your name by hand on your artwork before taking photos to prevent plagiarism. You need a picture of when you first started, the middle of the process, and the final product, all of which is to make sure that it is your original artwork. Okay, but yeah, don't worry too much about slides 4, 5, and 6. Just get started on your art. All right, get started on your art. That way you can start filling in these ones right here. But so far we did 7 and 8 on Friday, and now we're just doing 9. So we've only really done 3 slides together. All right? No, don't hate art. It just takes practice, right? We are not doing slide 10. Again, we realized today during the morning class that we didn't have time to do slide number 10, which the nice thing is because we're not doing assignments anymore, we have that flexibility. Cool. All right, everybody. I'm going to go ahead and move on here.
And transverse wave. On the other side is our definition. Again, I want you to go ahead and take your whiteboard tools. I just gave you access to those, and use a thin line to go ahead and match your term with your definition. I'm going to give you 30 seconds up on the board. Go ahead and get going on that. Good job. Let's go ahead and look at this together. Let me shrink this down so we can see what we are looking at. Beautiful. Beep. Our definitions here. I don't know what I was thinking. All right, here we go. So looking at longitudinal, we know that longitudinal waves are particles that move parallel to the energy, so absolutely I agree with you on that one. Remember, that's just how we took that slinky and we just kind of went back and forth with it. Transverse waves, on the other hand, are particles that move up and down to the energy. Okay, our guitar strings, so that's our example here with our transverse. Our transverse wave. And then finally our surface wave. I think of, when you think of surface, I think of surf. And when you think of surf, you think of the beach, and then you think of oceans. And obviously that's from what our example was, where we watched that little particle moving in a circle. So surface waves is that particle moving in a circular motion. All right, this is in your slide 9, so I'm going to go ahead and show you this really quick before we go here. So looking at our slide 9 here, you have these 3 different pictures. Obviously, you're going to match up with the pictures. So for example, our transverse wave will be this one at the very top here. I'm going to click and drag my slide up there, hold and drag my slide, or my picture right there, into the transverse. I'm also going to go ahead and pick one of the words over here on the side here. For example, particles who move perpendicular. That's going to be my transverse. I'm going to go ahead and move it up into my transverse section. So I'm going to have you go ahead and do the last 2. Make sure you do both the picture and the words. The picture and the words on that one. Picture and words. I'm going to give you 30 seconds to do that. 30 seconds is up on the clock. Here you go. Go, go, go. Green checks when you are finished. Make sure, yes, and make sure the right particular wave. So it's not going to be due for another couple of weeks. So we don't have something due every day anymore because we don't have an assignment. It's just due at the end of the Unit 4, which is the next, near the end of next week, yeah. Unit 4 is pretty short.
Excellent. So today's attendance should be super easy because you just finished slide number 7 for your project. So today's attendance is what is the exact example and particle motion that was given for you on the longitudinal wave on slide number 9. Please copy what you see from slide number 9 for longitudinal wave. Don't make up your own example. Please use the example that was provided for you on slide number 9. That is the answer. Click start a new thread. Tell me what's the example for the longitudinal wave shown in slide number 9 and what is the particle motion. So what do the particles do? Thank you so much, everyone. I will give you 1 minute to work on that, and then we will start logging students out. Speak now if you have an issue, or forever hold your peace. Otherwise, please go ahead and log yourself out. We'll see you tomorrow morning. Bye, everybody. Is this you, Mrs. Sepulveda?